Welcome back to the channel. My name is Tim Yoon, and I'm going to discuss some clean code principles, i.e. the solid principle, single responsibility principle, the open and close principle, and in the context of the design patterns of Gang of Four. The particular design pattern is going to be the strategy design pattern. And what that means is it's a way of encapsulating algorithms inside of objects, making the algorithms reusable and interchangeable at runtime. So the example I'm going to give is with regards to a player shooting a gun. Now, the gun that the player has could be a pistol or a rifle, any other type of gun. And I'm going to show you the example in Swift and SwiftUI. So I'm going to talk about how you might do this in a way that's kind of naive, where you might create an enum that's a gun, and you could have several different kind of guns. You could have a pistol and a rifle, and then the player could have a gun. For our gun as of type gun, and we'll say that there's a function called shoot. And what it does is it merely calls the shoot based on what the gun is. So we're going to say switch on the gun, and the gun has to be, I'm waiting for the Xcode to give me this, either a pistol or a rifle. Okay, so if it's a pistol, we're just going to say print pistol fired. Okay, and if it's a rifle, we'll say print rifle fired. Okay, so that's great. We'll do that and see how that works. Seems pretty simple, but I'm going to show you how this can go out of control in a little bit. So the example in SwiftUI would be a at state private var gun. Sorry, it would be a player of type player, and he needs to have a gun. So we'll say pistol gun dot pistol is what he gets. All right, and then we'll say, okay, here we'll create a button, and it'll be shoot. And when he shoots, the player shoots the gun. So it does shoot. And so let's see that example. Here's shoot, the button. We'll make it a little bit more visible, button style. And we'll say bordered from it. How about that? Okay, so when we shoot, you see that the pistol gets fired. That's cool. Now, what happens if we want to change the gun type to change to rifle? So what we'll do then is say player.gun equals gun.rifle. Okay, you can actually just say .rifle too. That's fine. Like .pistol also works right here. Okay, so we're going to change. So let's do that. Change to rifle. Boom, and then shoot. Oh, now the rifle is fired. So this works just fine. But the problem comes is that what if you want to have a shotgun? Okay, so now you got a shotgun, you created a new shotgun. Oh, now we have to add another case here to handle case dot shotgun, right? And then let's say this one is going to be shotgun fired. So what you just saw is that when you make a change in the gun, you have to make a change in the player. That indicates tight coupling. We don't like that. That means that this does not follow the open close principle and does not follow the single responsibility principle, because it's having to take care. It has to know about the gun and all this kind of stuff. So it's really not a good way to do this. So what's an alternate way of doing this? Okay, so what we could do is we can, instead of an enum, we could say there's a protocol called a gun, and it's going to have a func called shoot. Okay, and then what we could say is we could create a struct, and we could call a pistol. Sorry, struct without the colons here. Pistol, and it's a type of a gun. And you're gonna need another one. Let's see. Okay, I'm mistyping. So struct rifle gun. Okay, so now we're gonna get error messages and shoot. So now we'll just copy this over, put that in there. Pistol will, when you shoot, it says pistol is fired. For the rifle also, you're gonna put that little piece of code in here, so the rifle is fired. Okay. So now we got a rifle and pistol. They conform to the gun protocol, which has a shoot inside of it. Okay. So now the player can be done in a different way. So instead of a switch statement here, what we'll just do is gun.shoot. Okay. So as you can see now, the player has gotten a lot simpler. See, it's just gun.shoot. Very nice. So now when we go to create an instance of a player, you have to give it a gun. And so it could be a pistol like this. And now it should work just fine, except for when we go to do this, we're going to say gun equals rifle, like so. So now this should work just as it did before. So let's take a look. Let me clean this here with Command K. Shoot, pistol fired. This is what we expect because we initialized the player to start with a pistol. Then we can change the rifle to rifle, and then we're going to shoot again, and then the rifle fired. Now this is all great. So the beauty of this is now let's say you want to go in and create another type of a gun. We'll call it a shotgun, and it's a gun. And give it a second. And what you'll see is you need to implement this protocol step. And here we'll say print shotgun fired. Okay. Now what you notice is I created a shotgun. I did not have to change the player code at all. So there's a significant decoupling that has occurred between the player and the guns. Isn't that lovely? And that's because we have this protocol named gun that has a function called shoot, right? And so if we go over here and say, hey, button, and we're going to say change to shotgun, and we're going to say player.gun equals shotgun, like so. And it should work. Let me Command K to clean this here. First, you shoot the pistol. Pistol is fired. Then change that to a rifle and shoot again. And the rifle is fired. And then we change to a shotgun and shoot, and a shotgun is fired. And so what you can see is that the code is much, much more modular, and the player doesn't have to know about the details of what kind of gun you created here, you know. And so this is this gun then encapsulates the shoot algorithm, which then can be implemented in different objects. Now this could be classes or it could be structs, but I just chose to use structs here. And yeah, and so if you got many different kinds of guns, you don't want to have to keep adding a new switch case into the player. You don't have to touch player at all. So that achieves the open close principle, meaning that the behavior of the player can be changed at runtime, actually, by giving it different kinds of guns. Single responsibility principle is being respected. Loosely coupling or decoupling the code has been achieved. This is a much cleaner code. Hope you like that, and maybe you'll be able to use that in your code in the future.